program is organized by Addis Ababa City Administration Education Bureau in collaboration with Addis Media Network. I'm teacher Mamo. Today I will teach you about similar triangles. Okay, if you remember, in our previous lesson we have seen similar polygons. The first thing that we did in our previous lesson was we could define what a similar polygons are. Then after, we could see problems related with similar polygons. So now I will give you one more example regarding similar polygon. Then we proceed to the next topic, which is about similar triangles. Okay, so to add one more example regarding similar polygon, let's see this example. If the sides of a quadrilateral are 6 centimeter, 7 centimeter, 9 centimeter, and 12 centimeter, find the sides of a similar quadrilateral whose smallest side is 12 centimeter. Okay, so now whenever we say this example, in this example we have two quadrilaterals. Okay, the first quadrilateral contains sides 6 centimeter, 7, 9, and 12 centimeter. Okay, these are the sides of one of the quadrilateral. Here we are asked to find the sides of another quadrilateral whose smallest side is 12 centimeter. Okay, so one of the side is given. The thing that we are going to do is we need to calculate the remaining 3 unknown sides of a certain quadrilateral, which is similar to a quadrilateral whose sides are given here. Okay, so to answer this question, we need to properly apply the definition of similar polygon. Well, to remind you what the definition looks like, two polygons are said to be similar if two conditions are satisfied. If you say the first one is all pairs of corresponding angles must be congruent, this is the first condition that should be fulfilled to say the two quadrilaterals are similar. And the second condition of similarity of quadrilateral or similarity of a polygon is all pairs of corresponding, the ratio of all pairs of corresponding sides must be proportional. Okay, so having this definition in our mind, we will try to see how we can find the sides of the unknown quadrilateral. Okay, say the sides of the quadrilateral are 12 centimeter. Let us start from the smallest side. Okay, the smallest side of what the unknown quadrilateral is given. Say the smallest one is 12. The next unknown is x, y, d. Since it's a quadrilateral, we need to have 4 sides. So if these are the sides of the unknown quadrilateral, we need to apply the second conditions for similarity of a quadrilateral. Okay, so these two quadrilaterals are similar if the ratio of their corresponding sides are proportional. That means the smallest one, 12 over the smallest one here is 6. 12 over 6 must be the same as the next side, x over 7 Okay, here you need to consider these numbers or these arrangements are given in ascending order. Okay, so you need to understand that way. So this should be fulfilled. The next proportion is y over 9. Okay, y over 9. And the last proportion is d over 12. Okay, so this is the first step that you need to apply to find the unknown sides, right? So from these two, we can take 3 different pairs of equations so that we can determine the unknown variables x, y, z. Okay, so take the first two, 12 over 6 and x over 7. So whenever you take this, 12 over 6 is equals to x over 7. Clearly 12 over 6 is 2. 2 is equals to x over 7. So crisscross it. So 2 times 7 is equals to x. This implies x becomes 14. Okay, so one of the unknown sides of the quadrilateral is known now. So let's take 12 over 6 and y over 9. So whenever you take this, 12 over 6 is equals to y over 9. Since 12 over 6 is 2, you can make it 2. 2 is equals to y over 9 and crisscross it. So 2 times 9 is equal to y. So y becomes 18. So the second variable is known. Lastly, we can take this one and this. Okay, you can equate these two terms. Then you will have 12 over 6 is equals to z over 12. So this implies 2 times 12 is equal to z. So this implies z is equal to 24. Okay, so now we have x, y, z. Therefore, the sides of the second quadrilateral are, therefore, the sides of the second quadrilateral are 12 centimeter, 14 centimeter, 18 centimeter, and 24 centimeter. Okay, so these are the sides. You can also check whether your answer is correct or not by taking the proportions. Okay, if these are the sides of a similar polygon, you need to have the ratio of all corresponding sides must be the same. That means 12 over 6, okay? You can take the ratio of these two. 12 over 6 must be the same as 14 over 7. Again, you can take the ratio of 18 by 9. Lastly, 24 by 12. In all these cases, the ratio must be the same. If we have one ratio which is different from the other, we cannot say that the two quadrilaterals are similar, okay? So this is how we determine the similarity of quadrilaterals, okay? So next we have similarity of triangles. Similarity of triangles. Okay. Like we did for similarity of a quadrilateral and a similarity of a polygon, we will have a definition of similarity of triangles. Okay, so let us see what the definition of similar triangles looks like. So by definition, two triangles are said to be similar if the pair of corresponding angles are congruent and the ratio of the corresponding sides are proportional, okay? Triangles or two triangles are similar similar if these two conditions are satisfied. The first one, the pairs of corresponding angles are congruent. Okay, so this is the first condition to say the two triangles are similar. The second condition is all pairs of the ratio of all pairs of corresponding sides are proportional. Okay, so the ratio of the corresponding sides are proportional. So these two are the condition to say that two triangles are similar. Okay, if you see the definition of similarity of triangles and similarity of a polygon are similar, in both cases we have two conditions which are similar, right? So in our next discussion we will have a short and precise method or way of checking similarity. For the time being, let's see how we can apply this definition to check whether two triangles are similar or not. Okay, so let's take a certain example and then we will sense what the definition is saying. So let's see this example. If the figures below are similar, find the value of x and y. Okay, so consider these two triangles. The first one is a triangle with side x minus 2, y plus 3, say this is 5. And the second triangle is a triangle with side 6, 8, 10. Okay, so this example is saying that in this example we have two triangles with sides x minus 2, y plus 3, and 5. Okay, these are the sides of one of the triangle. In the second triangle, we have sides 6, 8, 10. Okay, here, if we consider these two triangles are similar, say the vertices are A, B, C, and here to make it clear, make it D, E, F. Assume that triangle ABC is similar to triangle DEF. If we have this information, based on this information, we can find the value of the unknown variables x and y. Okay, so to find these unknown variables, we will apply the definition of similarity of triangles. Okay, so what are the definitions? Okay, in the definition of similarity of triangles, we have two things, right? The first one is about the pairs of corresponding angles must be congruent. For the time being, we don't need that thing because it says the two triangles are similar. So the main thing that we need to apply here is we need to take the second condition for similarity. It talks about the ratio of all pairs of corresponding angles are proportional. So if we have this, we can say that triangle ABC is similar to triangle DEF, implies AB over DE is equal to BC over EF, and this is the same as AC over DF, okay? This is the first thing that we need to put to find the unknown variables x and y, right? Then after, we can substitute all the values of the sides in this equation. So the second condition on similarity of triangles can be applicable to find the unknown variables x and y. So we can find those unknown variables by taking these ratios, okay? From this ratio, AB is x minus 2, AB is x minus 2 over DE is 8, okay? DE is 8, and BC is y plus 3, BC is y plus 3, then you can write here y plus 3 over EF is 10, and AC is 5, AC is 5 over DF is 6, okay? So from these proportions, we can get these equations, okay? So taking the first part and the third part, we can equate these two things and crisscross, okay, to find the value of x. So this implies x minus 2 over 8 is equal to 5 over 6. Okay, now you can crisscross it. So whenever you do a crisscross, this implies 6 times x minus 2 is equal to 8 times 5, right? So now you can distribute the coefficients and obtain the unknown values. Okay, whenever we distribute 6, you get 6x minus 12 is equal to 40. Okay, 8 times 5 is 40. Now you can transform minus 12 to the right, you will get 52, right? So 6x becomes 52. Okay, this implies 6x becomes 52. Now dividing both sides by 6, you get x is equals to 52 over 6, or 26 over 3. Okay, the value of x in this case is 26 over 3, right? So to find the second variable, you can equate the second and the third term, right? This way, you can calculate the unknown values of x and y, okay? So this is how you can calculate the unknown sides. Now let's see some other example regarding similarity of triangles. In example 2, we have two similar triangles. Consider the triangles, the triangles below. If triangle ABC is similar to triangle DEF, find the value of A and B. Okay, here we have two triangles which are similar. Those triangles are triangle ABC. Say ABC is a triangle with side 2A minus 1 and 3B plus 2, and this is, say, 6. Triangle DEF is a triangle with side 10, 12, and 14. Okay, so here it's given that these two triangles are similar, and the side of one of the triangle is not completely known. Some parts of the triangle ABC are known, and the rest of the two are a triangle which is given the side of the triangles are given in terms of a certain variables. So having the condition of similarity of these two triangles, we can calculate the unknown variables the way we did in the previous example. So to find these two unknown variables, we can apply the second condition for similarity of two triangles, right? So those two things are triangle ABC is similar to triangle DEF implies the ratio of the corresponding sides are proportional. That means AB over DE, AB over DE is the same as BC over EF, BC over EF, and the third proportion is AC over DF. So AC over DF, okay? This is the first step that you need to follow to find the unknown variables. So in this proportion, we will substitute all these things, right? All the values of the given sides. So AB is 2A minus 1 over DE is 10, BC is 6, and EF is 12. Okay, then the last proportion is AC. AC is 3B plus 2, 3B plus 2, and DF is 14. Okay, so we have these sets of equation. Okay, by taking two pairs of equation, we can calculate the unknown variables. So take the first one. Okay, whenever we take the first equation, we will have 2A minus 1 over 6 over 10 is the same as 6 over 12. Okay, to make the calculation easier, you need to write the simplified form of 6 over 12. So clearly 6 is 6 times 1. You can make 12 is 6 times 2. So that way you can simplify 6 over 12 as 1 over 2. Okay? Then use crisscross. This becomes 2 times 2A minus 1 is equal to 10 times 1. 10 times 1, which is 10. So now you can distribute the number outside the bracket. Then this becomes 4A minus 2 is equal to 10. Okay? You can transform this minus 2 to the right side. Then this implies 4A is equal to 12. Lastly, what do you do to find A? Good. You have to divide both sides by 4 and obtain the value of A. So dividing both sides by 4, A becomes 12 over 4, which is 3. So this is the value of A, right? Then take the next pairs of proportions, okay? Whenever we take this, we obtain the value of B. So 6 over 12 is the same as 3B plus 2 over 14 means you can crisscross it, okay? 6 times 14, but this takes time, so make a simplification on the middle term. Take 1 over 2, then 1 over 2 is equal to 3B plus 2 over 14. Now this makes things easier. And crisscross it, this becomes 14 is equal to 2 times 3B plus 2, right? Then the next step is distributing this number. Okay, distribute this number, then you will get 14 is equal to 6B plus 4. Okay, now the next step is we need to transform this 4. Okay, or take both sides minus 4. Okay, you can subtract both sides minus 4. Then this becomes 14 minus 4 is equal to 6b. Okay, so this is the same as 10 is equal to 6b. Then lastly, you can divide both sides by 6. Okay, divide both sides by 6, then b becomes 10 over 6, or the simplified form of 10 over 6 is 5 over 3. Okay, this is 5 over 3. So our b value becomes 5 over 3. This is the value of b, right? Well, so the required answer in this example is a is equals to 3 and b is equals to 5 over 3. Look, here, if you substitute any other a value or any other b value, these two triangles cannot be similar, right? The ratio of the two triangles will not be proportional, right? For example, you can substitute a is equals to 4 here, or a is equals to 5 here, then you can see that the ratio of the corresponding sides are different, right? I will give you for this thing for you to check whether the triangles are similar or not if you take any a value other than 3. Okay, so this way you can find the unknown sides. So let's see one more example regarding similarity of triangles, and that will be the end of our discussion for today. So this example contains given triangle ABC. Triangle ABC is similar to triangle PQR as shown in the figure below. In the figure below, find the value of B. Find the value of B. Okay, the triangles are triangle ABC, okay, triangle ABC, and PQR. The sides of this triangle are, this is 7, okay, this is 8, say this is 5, okay, and the sides of triangle PQR are, say this is 3b plus 5, okay, 3b plus 5, and say this is 16, and the third side of triangle PQR is 10, okay? Here in this example, it's given that triangle ABC and triangle PQR are similar. Then, based on this information, we are asked to find the value of B. Okay, as we did before, the first thing that you need to do is putting ABC is similar to PQR. Okay, so now you can take the ratio of the corresponding sides are equal. So that means AB over PQ, AB over PQ must be the same as BC over QR, BC over QR, and the third proportion is AC over PR. Okay, this is the first step that you need to follow. Then next you need to substitute everything in this equation. So AB is 5. So here it's PR. Okay, so AB is 5 and PQ is 10. PQ is 10. BC is 8. BC is 8, and QR is 16, and the last ratio is AC over PR. Okay, this is P. Okay, so AC over AC over PR means 7 over 3b plus 5, okay? So this is the first step that you need to follow to find the unknown variables. You can have one variable, more than one variable, whatever the case. So taking these two, we can calculate the value of b, okay? So here, to make things easier, you don't need that to take directly 8 over 16, okay? To make your calculation easier, please take the ratio of 8 and 16 in the most simplified form, okay? The simplified form of 8 over 16 is 1 over 2. This is the same as 7 over 3b plus 5, okay? Now you can take a crisscross on both sides. So this means 1 times 3b plus 5, which is 3b plus 5 is equal to 2 times 7, right? So 2 times 7 is 14. So this implies 3b plus 5 is equal to 14. Now you can transform 5 to the right side. Then this equation becomes 3b is equal to 14 minus 5. This is 9, okay? So 3b is equals to 9 means dividing both sides by 3, okay, b becomes 3, okay? So the unknown value of b here is 3. Here, you can check by taking any different value of b in this equation. Then, if you take any other value of b, you cannot find that the two triangles are similar. Okay, these two triangles are similar only whenever b is 3. So this is all for today. I hope you enjoyed the lesson. Thank you for listening.